Hello crafters, welcome back to Code Crafters. In today's video, we are going to explore arrays in C++. Arrays are essential for storing multiple values of the same data type under a single variable name, and we'll be diving into the basic concept of what actually arrays are. So, let's get started. Arrays are fundamental data structures used to store collections of elements of the same type. They offer an efficient way to manage large datasets and are widely used in programming for various tasks. An array is a fixed-size collection of elements that belong to the same data type, meaning all elements must be of a uniform type such as integers, floating-point numbers, or characters. Arrays are stored in contiguous memory locations, allowing for efficient access and manipulation. The elements in an array are enclosed within curly braces and separated by commas when initialized. Arrays are particularly useful in managing a large set of related data under a single variable name, thus reducing redundancy and improving program efficiency. By using arrays, developers can store and process multiple values collectively instead of declaring multiple separate variables, making arrays an essential part of structured programming. Arrays allow the storage of multiple values of the same data type, making them highly efficient for handling bulk data. One of the primary advantages of arrays is their ability to provide direct access to any element using an index, where indexing typically starts from 0. Because arrays use contiguous memory allocation, they help minimize memory fragmentation, leading to better performance in terms of speed and resource usage. Operations such as traversing, searching, sorting, and modifying elements can be performed efficiently using loops, enabling programmers to work with large datasets effectively. This structured and indexed storage system makes arrays an essential tool for problem solving in programming. The syntax for declaring an array follows a specific pattern. Data type array name array size. For instance, to declare an integer array of size 5, the syntax would be int array 5. Array initialization involves assigning values within curly braces during or after declaration. A fully initialized integer array would look like this. Int array 5 equals 1, 2, 3, 4, 5. Here, 5 integer values are stored in consecutive memory locations. If an array is declared without explicitly assigning values, the elements are often set to 0, in some languages, or contain garbage values, in languages like C++. Proper initialization ensures that the array is usable without undefined behavior. A one-dimensional array is the simplest form of an array, representing a linear sequence of elements stored in contiguous memory locations. Each element is accessible via a single index. Consider the example. Int array 5 equals 1, 2, 3, 4, 5. In this case, the elements are stored sequentially in memory, forming a single row of values. One-dimensional arrays are commonly used in scenarios such as storing student marks, temperature readings, stock prices, or any data that follows a linear pattern. Their simplicity and efficiency make them a fundamental structure for storing and retrieving ordered data in programming. A multi-dimensional array extends the concept of one-dimensional arrays by allowing data to be stored in multiple dimensions. The most common form is a two-dimensional array, which can be visualized as a table with rows and columns. A three-dimensional array adds another layer, forming a cube-like structure. The syntax for declaring a two-dimensional array is int matrix 2 3 equals 1, 2, 3, 4, 5, 6. Here, the array matrix contains 2 rows and 3 columns. Multi-dimensional arrays are widely used in various applications, such as storing matrices in mathematics, representing pixel data in image processing, and managing spatial data in scientific computing. They provide an effective way to model real-world data structures that require multiple layers of organization. Multi-dimensional arrays find extensive use in fields like image processing and spatial data storage. In image processing, a two-dimensional array can be used to store pixel intensity values, where each element represents the brightness or color of a specific point in an image. For example, Grayscale images can be represented as a matrix where each value corresponds to a pixel's brightness. Similarly, in spatial data storage, three-dimensional arrays can be employed to store geographical coordinates or 3D models, making them useful in applications like computer graphics, scientific simulations, and GIS, geographic information systems. Their structured nature allows efficient manipulation and transformation of complex data sets. In summary, arrays are fundamental data structures that facilitate organized and efficient data storage and manipulation. Whether dealing with simple lists or complex multidimensional data sets, arrays play a crucial role in programming, enabling effective problem solving across various domains. Thank you for watching, and happy coding.